LeBron and Trina are talking about our sun and other stars. Tina argues that the sun is much larger than all the other stars in the sky. She also explains that most of the other stars are about the same size as each other and the same distance from Earth. LeBron disagrees. He explains that the sun looks larger than the other stars because it is closer. He also argues that the other stars vary a great deal in size and distance from the Earth. I, if I had the, I think who's right is LeBron because the distance, like what factors contribute to distance, temperature, and size, and not everything is the same size. Like if it's the sun, which LeBron explained, it's closer up, and then there's those other ones because she thought just because it's close up it's big, it's a biggest star, and that's not true. Sometimes it's the smaller star. Most of the time the closer up stars are, that's only because the distance is closer to our Earth and we can see it more. And when it's farther away, it doesn't mean it's smaller than the sun. It could be bigger. This shows the size of each thing, and these are bigger like these are way bigger, but they're farther away from the Earth. Like the sun is right here, and it says in right there, it shows that the sun is big, but there are other stars that are bigger than it, that are farther away, but the sun you can see easier, and it comes down so you can see it more.
I'm not saying that orange and red isn't hot. It's still like 2,000 something degrees Celsius. But
yeah, and this also shows that blue is way hotter than the red, and like red is very, very, very hot, but blue is like so hot. Red is 3,000 degrees Celsius, but blue is 300 or 30,000 degrees Celsius, and that's so high in Fahrenheit that if you even got close to the red one, you would get melted. And the distance, it doesn't even matter by the distance. Spectral color, the spectral color, temperature, and lunacy. So on this shows what the temperatures are. Bluish is 3,100 degrees, and bluish white is from 9,000 degrees to 700, or 9,750 degrees to 3,000, or 31,000 degrees. White is 7,100 to 9,750. Yellowish white is, these are so hot. Yellowish white is 5,950 to 7,100. Yellowish is 5,250 to 5,950. Orange is 9,000 or 3,950 to 5,250 degrees. Reddish is 2,000 degrees Celsius, which is the lightest degrees. That's crazy. To 3,950 degrees. This shows all the temperatures on the scale that I was showing here, and it shows that it doesn't really matter because the sun is in the yellow part, and these other ones are in the blue part, but we can't really see them that well. But the sun is closer, so we can see it. But that doesn't mean it's bigger than those other planets. The larger of two stars with the same temperature at the same distance is brighter.
But that's only because it is so
And
much closer than all the other stars.
yeah, the largest
This
of
one is
two
with
stars
the,
with the
if we
same
pretend that this was
temperature
the same star,
at
this
the
was
same.
the same sun. It appears
Wait.
to be a
The
lot
largest of two
smaller,
stars
but it's
with the
really
same
the
temperature at the same distance is
same
brighter.
size, but it's just a lot farther away.
So this shows
This would be the
that
star.
this is the same, the larger of two stars with the same temperature at the same distance is brighter. So this shows that if if this star was just moved over there, they look exactly the same, but they're both, this one is bigger than that one, and this one is smaller than that one. But when it's looked back, they all look the same. So they all look, hey, all the stars are the same. But no, there's way different sizes. Over like a bunch of height is way over, but it looks like they're the same exact stars. So yeah, that's all the questions filled out, and I'll see you in the next video.